Hello everyone. The first question is answered by Lenny Lao Yixian. The second question is answered by Winnie Lao Yihui. The third question is answered by Chao Qianyan. The fourth question is answered by Ling Bongxi. The mass of the bucket is 0.500 kg. The force applied is 200 Newton. The distance for the person to pull the bucket is 6 meter. The angle of the rope is 45 degree. The force for S component is equals to 200 cos 45 degree. The force for the Y component is equals to 200 sine 45 degree. Before we find the work done, we should find the force first. The force is equals to force for the S component. So the equation is 200 cos 45 degree. The answer is 141.42 equals to 141 Newton in three significant figures. Now we can find the work done. The formula of the work done is W equals to force times distance. The force is 141, the distance is 6 meter, equals to 848.52, equals to 849 joule in three significant figures. The answer should be in three significant figures because the values in the questions are all in three significant figures, so the answer should be in three significant figures. In this question, the angle is changed to 30 degrees and the distance is remain unchanged, which means that the distance between the person and the basket is 6 meters. The force applied is 200 Newton. The question wants you to find the work done. W is equals to force times distance. The question gives you the distance which is 6 meters and you need to find the force. Force is equals to 200 cos 30 degrees equal to 173 Newton. Now you know the force and the distance, so you can find the work done equal to 173 times 6 equals to 1038 joule. The question also wants you to compare the angle, which angle will produce a larger work done. By comparing the value from question A and question B, we can conclude that 30 degree will produce a larger work done compared to 45 degree. This is because 30 degree produce larger effective force than 45 degree. So 30 degree will produce a larger work done than 45 degree.
In this question C, the person takes 5 seconds to pull the bucket with 5 Newton force at an angle of 10 from the horizontal along BC, which is an inclined plane with rough surface. The coefficient of friction at BC is 0.5. Determine the kinetic energy of the bucket when it reaches point C. Now let us look at this diagram. This is an inclined plane BC with an angle of 45. The round dot here represents the bucket. Weight equal to mg is acting downward. The vertical component of weight on the inclined plane is perpendicular to the inclined plane, which equal to weight times sine 45 degree. The horizontal component of weight is parallel to the inclined plane, which is weight times cos 45 degree. Normal force is opposite to vertical component of weight on the inclined plane. The force pulling the bucket is 5 Newton, and the angle is 10 degree from the horizontal on the inclined plane. Here is the diagram which simplifies the diagram above. The vertical component of weight is mg sine 45 degree. The horizontal component of weight is mg cos 45 degree. Since the force pulling the bucket is 5 Newton and the angle is 10 degree from the horizontal component of pulling force is force cos 10 degree and the vertical component of pulling force is F sine 10 degree. Now we need to find the R, which is the normal reaction. The normal reaction plus the vertical component of force is equal to vertical component of weight. So normal reaction is equal to the vertical component of weight minus the vertical component of force, which is mg sine 45 minus force sine 10. The mass is 0.5 kg, g equals to 9.81, and the force is 5 Newton. Therefore, the normal reaction is equal to 2.60 Newton. Next, we need to find the frictional force. Frictional force is equal to the coefficient of friction times the normal reaction. The normal reaction is equal to 2.6 Newton and the coefficient of friction at BC is 0.5. Therefore, frictional force is equal to 1.3 Newton. Next, we need to find the magnitude of resultant force. The direction of force pulling the bucket horizontally and the direction of frictional force are in opposite direction. The resultant force is equal to the horizontal component of pulling force minus the frictional force. The force pulling the bucket horizontally on the inclined plane is equal to 5 cos 10 degree and the frictional force is 1.3 Newton. Therefore, the resultant force is equal to 3.62 Newton. Next, we can find the acceleration of the moving bucket by using Newton's second law, which is F equal to ma. The resultant force is 3.62 Newton and the mass of the bucket is 0.5 kg. Therefore, the acceleration of the moving bucket is equal to 7.24 meter per second to the power of 2. In the next step, we can use the acceleration to find the velocity of the moving bucket by using the formula v equal to u plus at. The v stands for final velocity, u stands for initial velocity, a stands for acceleration, and t stands for time travel. Since the bucket starts moving at point B, the initial velocity of the bucket is 0 meter per second. The acceleration of the moving bucket is equal to 7.24 meter per second to the power of 2, and the time travel from point B to point C is 5 seconds. So we can calculate that the final velocity of the moving bucket is equal to 36.2 meter per second. Next, we can find the kinetic energy by using the formula 1/2 times mass times velocity squared. The mass of the bucket is 0.5 kg and the velocity of the moving bucket is 36.2 meter per second. The kinetic energy is equal to 327.61 joule.
For this question, we need to find resultant force AB and CD to compare them. For resultant force AB, we have the information that the angle is the same as A, that is 45 degrees. So we can find the horizontal resultant force. We need to look at the negative sign here because the force is toward the left. So it's negative 200 plus 45, and then we will get negative 141.40 Newton. For resultant force CD, we have the information that the coefficient of static tension is 0.5. So we can render the formula minus the friction goes to entry. Coefficient of static friction, you know that is 0.5 times mg minus normal force equals to m0 because it is a static friction, so there is no acceleration. So substitute in the value. M is 0.5 times G971 minus the normal force 200 sine 45 equals to 0. And then 0.5 times 9.81, you will get 4.945 minus 200 sine 45 is 141.421 equals to 0. You can move everything to the right hand side. This will be equal to negative 136.516. And you'll get the final answer, negative 68.258 Newton. 3 will become to 0, that will be equal to negative 68.3 Newton. And also for AB, negative 141 Newton. Okay, so now we have both AB and CD resultant force. And we know that AB, resultant force AB, is larger than resultant force CD. Because there is friction between CD, so the resultant force will be smaller.